Professor, you're muted.
How's that? Any better?
Yeah, that's good. Thank you.
Okay, thank you. Thanks for letting me know.
Mhm.
So whenever we talk about sample versus population, lowercase letters represent samples, capital letters represent population, alphabetic letters use are samples, but then to represent the population, we use Greek letters. That's going to be apparent in the next section. More so in the next. So when we talk about measures of center, what we're talking about there are the mean, the median, and the mode. Because each one of those three deal with something relative to the center of the data. The first one, mean, even though we describe it as an average, it's not really an average. It's gonna be clear in a little bit. Because how do you find an average of two numbers? Add them together and divide by 2. Yes. That's pretty much what you're doing here. The mean, all your data points, the X, we use that Greek sigma, the Greek S, add up all the data set and divide by how many you have, N. Whenever we talk about the mean, the way we represent that for samples is X with a bar over it. It's a lowercase x with a bar over it. If it's a capital X and a bar over it, it's the population mean. What is a median? It's the middle. Like if you ever take a turn too short on a road, you feel that bump, that's the median, because that's in the middle of the road. The median it's a procedure. I can't write down right there. It's a procedure to find the middle. Because depending if we have an even or an odd number of data points, it'll give us a different process. What's mode? What's that? The most frequently occurring. Yes. The mode is the most frequently occurring. In fashion, they call it mode du jour, the mode of the day, the fashion of the day. It's what most people are wearing. For example, this drives me up the wall, is when people tuck their sweaters over their belt. That's just, it annoys me so much. But that's the mode. And in fashion, it's how unoriginal can you be? Okay, so we know that X bar represents the mean, the average. The median is represented by the X with a squiggle over it. That squiggle is called a tilde. So it's X tilde. It's an X with a squiggle over it. And the mode is represented by a dot. X over this was called X dot. All right, in your package, we're just going to look at the first column. The data set we're using today, or in this section, is the Disney World wait times at some of the most popular rides. So we have Space Mountain, we have It's a Small World, the Rock and Roller Coaster, the Tower of Terror, the Flight Passage, that's the Avatar Flight Passage in Animal Kingdom, and the Navi River, another ride at Animal Kingdom. What we did here, what the data was collected was at 2 times a day, in the morning at 10 o'clock and at 5 o'clock PM. And this is the stuff, actually, this data, you can see, if you ever go into a park or anything like that, a theme park, they will usually have this kind of data you can ask for. Why would you want to do that? Yes, to see when the best time to go to the park is, or when's the best time to go to this ride. So let's look at the first Space Mountain at 10 o'clock. We're going to use that data set for right now. So our X's are going to be 50, 25, 75, 35, and 50. So to find the mean, we have to add up all that data, all those data points, and divide by how many we have. So if we add them up, we have 5, 10, 15, carry the 1, 10, 23. So it's 235 divided by 1, 2, 3, 4, 5. Divided by 5. 5 goes into 23 4 times with 3 left over. 5 goes into 35 7 times. So the average wait time is 47 minutes. Depending on what time of the day you go. The average wait time is 47 minutes. These are all in minutes. What's the mode? Which one's the most frequently occurring? We had 50, 25, 75, 35, and 50. 50 is the most frequently occurring. Okay, now the question you can ask is, why is mode there in the measure of center? This topic is also called a measure of central tendency, how things relate to the middle number. Mode really doesn't. Mode has nothing to do with the center. It's just what number occurs most number of times. It's just they threw it in there. Now, to find the median is a process to find the median, X tilde. First step. Arrange the data in increasing order. So first step, arrange your data in increasing order. So our data is going to be 25, 35, 50, 50, 75. All right, second step. Take the number of data points, n, and divide it by 2. This is where it's dependent on whether there's an even or an odd number of data points. If n is odd, for example, in this case, we have 5 divided by 2. 5 divided by 2 is 2.5. If n is 5, if n is odd, you're always going to have a decimal in there, 0.5. So round up to the next whole number. So we're going to round it up to 3. And that is the location of the median. So we took 5 divided by 2, we get 2.5, rounded up to 3. So our median is in the third spot. It's 25, 35. The third number is 50. So our median here is 50. That's if your n is odd. Let's look at if it's even. Let me add another number here. Let's add 80 in there. So we got 25, 35, 50, 50, 75, and 80. Now our n, 1, 2, 3, is 6. If n is even, divide n divided by 2. It's going to give you a whole number. So in this case, 6 divided by 2 is 3. Go to that location and get the number. So the third number is 50. Also, get the next number in line, which is also 50. Add them together and divide by 2. That will give you the median of a even number set. So we got 50 plus 50 over 2. 100 divided by 2 is 50. So again, the median is the physical number, the number in the physical middle part of that data set. And we know the mode already. The one that was odd was the third number. 1, 2, it's also 50. This one happened by chance. It doesn't have, the median does not have to be a number in the data set. Neither does the average. The only number that has to be in the data set itself is the mode. The other two are simply calculations. Let's see here. Oh, look at the properties. The important properties of the mean. Sample mean drawn from the sample population, same population, tend to vary less than the other measures of center. Okay. because you're just adding all of them up. The mean of the data uses every data value. The disadvantage of the mean is that just one extreme value, an outlier, can screw the whole thing up. So if we have an outlier, in other words, in our data set, if we went from 25, 35, 50, 50, 75 to 300, that outlier is going to change the whole structure of it. Because in our data set, we have 1, 2, 3, 4, 5.
Oh, okay. I was looking at that one.
Yeah, these are also, well, this, I just put up there, but we only had 5 data sets originally. We took those. Yeah, I'm sorry, yeah.
No, I got you.
And remember what the formula for N was? What does N represent? The number of data points. Just count them. All right, so there you have the formulas for mean, median, mode. So let's look at example 1. This is a bigger data set. Our data set now is 50, 25, 75, 35, 50, 25, 30, 50, 45, 25, 20. That's a lot. So the first thing we're going to do, what would be the easiest of the 3 to find? Mode, yeah. Because all we have to do in mode, to help find the mode, it's the first thing we do is put in increasing order. Organize them. So we have 25. There's another 25. There's another 25. Do we have a 20? Oh yeah, we have a 20. Then we have 130. A 35. Oop. We have a 45. We have 3 50s. And a 75. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Always make sure that you have the same number of data points you started off with. So should we start off with 11? 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. We ended up 11. So which one's our mode? Okay, 50 has 3. Does any other one have 3? Yes. Now, what this if you have more than one mode, depending on the size of your data set, if it's small, then you can say there's no predominant mode. But this is it's bigger than 10. So when we say if we have 2 modes, that's called bimodal. Bi means 2, mode means the mode. So it's bimodal. So the mode in this case, x dot equals 25 and 50. The next easy one would be the median. Remember, first step in median is put them in increasing order. Check. Second step, take n and divide by 2. So we have 11 divided by 2. 5.5. What do we do if we have a decimal? Round it up to the 6th location. So the median x tilde is the 6th number. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. The number is 35. It's the 6th number in our data set once it's arranged.
Professor, I have a question. How did you
Yes.
got the 11?
11 represents the number of data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Oh, okay.
Yeah, so n is the number of data points. Now the mode. Not the mode, mean. This one's the most difficult one. Not difficult, but it's the longest one because we have to add them all up and divide by 11. So we have 50 plus 50 is 100. 75 plus 25 is 100. 25 is a 50, so 50 plus 50 is 100. 20 plus 30 is 50. 50 plus, that's 95. Makes it 100. That's a 30. So we have 1, 2, 3, 430 divided by 11. So in this case, it's 39.1 minutes. We take 430 divided by 11. What was it our first time? When we just did 5 numbers? Remember the first time we did it was 47. But then we only used 5 digits, 1, 2, 3, 4. We just used the first 5 data sets. Now we use 6 more. So what does that tell us? Yeah, the more data set you have, the more accurate your result's going to be. Because when the mean, when we had 5, was 47. The mean, when we had 11, is 39.1 minutes. Doesn't sound like much, 8 minutes, but trust me, when you ever go to an amusement park and you have to wait 8 more minutes, it does get to you. So what do y'all think? Pretty straightforward? That's the mean, median, mode. Oh, let's look at this. The next data set. Example 2. Let's do example 3. We just did something with example 2. So we have our data set was 50, 25, 75, 35, 50, 25, 30, 50, 45, 25, 20, and 50. 2, 4, 6, 8, 10. Now we have our N is 12. Let's see how these numbers change. The first thing we want to do is what? Put them in increasing order. Yeah. So the smallest number we have is 20. Then we have a 25. We have another 25. And we have another 25. Then we have a 30. A 35. 45. A 50. A 50. A 50. Another 50. And then a 75. So what is this? What does X dot represent? Mode. So which one occurs the most? 50. Very good. It happens 4 times. Let's do the median. X tilde. First step is put them in increasing order. Second step, take N divided by 2. We got 12 divided by 2 is 6. What do we do with that? Go to the 6th number. 1, 2, 3, 4, 5, 6. That's a 35. And do what? Go to the next one, which is 45. Add them together and divide to perfect. So 35 plus 45 is 80. Divided by 2 is 40. So the number between 35 and 45 is 40. That's our median. And the last one, the mean. We add them all up. So we have 100, 200, 300, 50 plus 50 is 400, 445 divided by 12. Calculator. Four, 4, 5 divided by 12. 37.08333 and forever. Note, whenever we have a repeating decimal, it's the same number or same series of numbers, we put a bar over those numbers. That means that number repeats itself forever and ever and ever and ever and ever. So it's 37.083 with a bar over it. 0.083 with a bar over the 3 because that 3 goes on forever. But how do we put our answer? We only, here's the rule of thumb. Your answers will only have 1 decimal place more than your data set. So since our data was integers, how many decimal places we're going to have? Just 1. So we have to round it to the first decimal place. since we have 37.08, we're rounding it to the first decimal. Look at the second decimal place. Right, it'll be 0.1. So if this number, the second number is between 0 and 4, just drop it. If it's between 5 and 9, then add 1 to the first decimal place. So then we'll come up with 37.1. That's our answer. Since we're only rounding to the first decimal. So that's a rule of thumb that we have. There's one more that's used, but it's not really used. So we have the mean, median, and mode so far. Now let's look at something called the mid-range. The mid-range, that's just another way of saying midpoint. You can think of it as a midpoint from algebra. The way we find it is take the lowest number, add the highest number, and divide by 2. Which means that we have to go through our data set and look for the lowest number and the highest number. In the one we just did, our lowest number was 20. Our highest number was 75. So if we add both of those, we get 95 divided by 2. 2 goes into 9 4 times with 1 left over. 2 goes into 15 7 times with 1, so it's 0.5. It's 47.5. So that was example 5. Ooh, critical thinking. Any questions so far? That was example 5, yeah. But as I was saying, is a lot of the stuff we do already, and so we have to redo it as a separate example. Critical thinking. Let's look at example number 6. Because things aren't always as they appear. And I'll put these up there. I'll read them out to you. See each of the following, illustrating situations in which the mean and median are not meaningful statistics. Zip codes of the Gateway Arch in St. Louis, the White House, Air Force Division of the Pentagon, Empire State Building, and the Statue of Liberty. So the St. Louis Gateway Arch is 63102. The White House is 20500. The Pentagon is 20330. Empire State Building is 10118. And the Statue of Liberty is 10004. You can't do anything with those. Why can you not do anything? Why is the mean and median mean nothing with those two? There's no correlation, and they're not quantified numbers. They don't represent numbers. They represent a location. So it means nothing there. Ranks of selected medical schools of Harvard, Johns Hopkins, New York University, Stanford, and Duke. Ranking them in order, 1, 2, 3, 4, 10. Again, finding the average doesn't tell you anything about those schools because they're not really quantified numbers. They're qualitative because they refer to a description. Number 3. The number of jerseys of the starting offense of the New England Patriots when they won the Super Bowl. Again, those numbers mean nothing numerically. They're simply labels that represent the individual players. So those are just examples of them. And then we see the wait times of the Rock and Roller Coaster and the Tower of Terror. The Rock and Roller Coaster is 15 minutes, 20 minutes, 45, 45, 45, 55, 55, 70, 75, 95, and 110. Wow. The Tower of Terror, 45, 45, 45, 50, 50, 55, 60, 60, 65, 75, 80. So by looking at those think about those numbers, which ride do you think is a better ride? Which one? Who thinks Rock and Roller Coaster is? The top one, yes. Why would you say that? Yeah, but wait time is also 15 minutes in the low end. And the high end, you're right, it's 110 minutes. That's close to 2 hours to wait. And I've done that before. The Tower of Terror, it's all the way between 45 and 80. We can't tell by looking at the data which one's a better deal. Because if you pick the Rock and Roller Coaster, remember, what you're looking at the low end, you're looking pretty much at the high end and low end. If you look at that, what that's saying is when you go in line, you could be lucky. Yeah, one of 3 things can happen. You could be in the 15 minutes, you could be in the 55 minutes in the middle of the whole pack, or you could be in the 115 minutes. But in the Tower of Terror, it's always busy. It's always a consistent line. So no matter when you go, you're going to look at either waiting 45 minutes to 80 minutes to go in line. So out of the two, the better ride looks like Tower of Terror because it's always busy. And the graphs of those, the dot plots, are listed right below. And the Rock and Roller Coaster is pretty much flat, except for a couple of bumps in the middle. You have a couple in the 15 and 115, but then it's spread out. The Tower of Terror, it's all condensed right in the middle. But we can't tell anything with what we've learned so far. The mean median mode doesn't tell us anything about which one's a better ride or not. That is what we're going to have to do in the next section when we talk about variance and deviation. All right. So far we had pretty small data sets. What if we had larger data sets? How would we do that? For example, remember the LA commutes? Yesterday's examples were the LA commute time. We had between 0 and 14 minutes. We had 15 to 29 minutes. 30 to 44 minutes. 45 to 59 minutes. 60 to 74 minutes. 75 to 89. And the last one was 90 to 104. Then we had the frequency of how many times those numbers occurred. 0 to 14 happened 6 times. 15 to 29 happened 18 times. 30 through 44 has happened 14 times. 45 to 59 is 5 times. 60 to 74 is 5. And the last two were 1 time each. So how would we find the mean, median, and mode here? The mode's easy. Which one would the mode be? Exactly, it's the 18 one, because by definition, the mode means the most frequently occurring. Since this is frequency, the biggest frequency. So what we say here, since it's not a number, it's a class, we say that the modal class is between 15 and 29. That's a modal class, because since our initial data set is no longer in individual numbers, they're in classes. We do the same thing with the median, but now we find the medial class. The medial class is, we'll figure that out in a second. How do you find the median? First step? Nope, not for the median. We'll put them in increasing order, and we just did that. Since we have a frequency chart here, we put them in increasing order. So check that. Second step of the median. Take n divided by 2. So what is our n here? How do we find n? Frequencies. Very excellent, beautiful. So the summation of all the frequencies is n. And we know that was 50 from yesterday. So we had 50 numbers, divided by 2, we get 25. So since it's even, we have to go to the 25th number and the 26th number, add them together, and divide by 2. Well, where is the 25th number? So to find the medial class, we have to find the cumulative frequency column. So in order to find the medial class, we have to calculate the cumulative frequency column. Remember, cumulative frequency is a running total of all the frequencies. So the cumulative frequency, the first one starts off at 6. Now in the second row, we have these 6 plus 18 more. That equals 24. Then we have those 24 plus the next one is 14. That gives us 38. And these 38 plus the next 5 makes it 43. 43 plus the next 5 makes it 48. 48 plus that next one is 49. And then 50.
So the cumulative frequency is different from the sum.
But what is, it's a running total of each row of the classes. You keep on adding all the numbers before there. So all the numbers that are before the third class or below, there are 38 numbers. So we know that from 30 to 44 and below, there are 38 pieces of data. So it just keeps on counting up to the next level set. And it's also a way we can check to see if our calculations for n were correct, because the cumulative frequency and the n should be the same number at the very end. So in our case, we have to go to the 25th and 26th number. What is the 25th number? Remember, our cumulative frequency is 6. There's 24 there. So the 25th number is in the next class, is in the third row. The 25th, this row here contains all the numbers, the frequency numbers from 25 to 38, all go in there. 25, 26, 27, 28, all of them belong in this class. So the modal class, since both of them are inside there, the modal class is 30 to 44. Yes. Which one? This one? Because if we add up all these numbers, 14 plus 6 is 20, 30, 48, 49, 50. And this, we add up all the frequencies. These are these. The cumulative frequencies. So this one's a running total. So in the first row, we have how many? 6. In the next row, we have these 6 plus these 18, which is 18 plus 6 is 24. So now we have 24 up to here. Then we add 14 more. So it's these two, give me that. These two, give me that. And then these two, give me that, and so on and so forth. Got it? Yes. Once you see it, it makes sense. So it's, you add the previous frequency plus that next frequency, and then keep on adding the frequencies there on down. Now, the mean, whenever you have a data set that has a frequency column, remember our mean was X bar equals summation of X over N. But we can't use that formula because summation of X only works if you have all the data set. Okay, so how do we find the mean? To find the mean of an interval, we have to first find the midpoint of each class. Because we need to have one number that represents that set. So between 0 and 14, how do we find that number? Yeah, so add the two numbers, divide by 2. So we get 14, so it makes it 7. This is going to be our midpoint ends. So what's the next one going to be? Between 15 and 29. $15 and $29. It's 44 divided by 2 is 22. 29 plus 15 is 44. Divided by 2 is 22. Since we know our data set, or each class is 15 numbers wide, that means the distance between all of our midpoints are going to be 15 numbers. So if we add 15 to 7, we get 22. 22 plus 7, 22 plus 15, I mean, 22 plus 15 is 37. Add 15 again. We get 52. Add 15, we get 67. Add 15, we get 82. And add 15, we get 97. So you could find those midpoint numbers either way. You can add the two numbers on the range, or you could just, since we know the width of the sets of the classes, we can just add that number to each previous one. All right, this is what we needed. We needed to have the midpoint number that represents this class, and we have the frequency. The formula we're going to use now is we have to take the summation of x n times f over n. So we have to first multiply all of our midpoints times the frequencies, add them up, and divide by how many we have. So we have, so in the first one, the midpoint is 7 and the frequency is 6. So 7 times 6 is 42. Next one, we have 22 times 18. 360 plus 36 is 396. Then we have 14 times 37.
It's 518.
Thank you. Then 5 times 52, 260. 5 times 67, 335. 1 times 82 is 82, then 97. Now we have to add up all those. $1,730, 1,730. Divided by n, which is 50. That's 34.6 minutes. Yes. Yes. No, those aren't the actual data. What those are the numbers. Basically, what we're doing here is the frequency is 6 and the midpoint is 7, so we get 42. It's the same as if we had, let's say 20, 20, and 20. We can add 20 plus 20 plus 20 is 60, or we can take 20 times 3 is 60. That's all we're doing. Whenever you multiply the number times its frequency, you're actually adding them. This is faster. That's where multiplication makes it faster. So we're just, instead of that, that number 42 doesn't represent a data point. It it represents the summation of all those numbers in that in that class. That's a good question. Very good question. Yes, yes. Because you need to have a solid number to do these calculations. And so if we have a class, an interval, we need to take the midpoint of that because that averages everything inside there. So what you can look at that formula, the x times summation of x times the f, that's the weighted frequencies. So we have the number and the weight of that number is how many times it occurs. Okay, yes. So yeah, what we're looking for here now is weighted mean. The weighted mean is the x bar equals x times the weight over n, or x times the weight of that divided by all the weights. A perfect example for this is calculating your grade point average. Yeah. How many have ever done that? Yes. We used to always do that. After every test, we calculate what's our average now, what's our average now. So what do we need to make a B to pass the course? So here's example 8. In her first semester of college, a student of the author took 5 courses. Her 5 grades, along with the number of credits for each course, were for A, the A course was a 3-credit course. She made an A in the second one, which was a 4-credit course. She made a B on a 3-credit course. She made a C on a 3-credit course. And she made an F on a 1-credit course, like a PE. So typically classes are 3 credit, 3 hours each. A 4-credit course would be something like a lab, physics, chemistry, biology, computers. And then 1-credit course is usually a PE. Now, typically the weights of these, an A counts 4 points, a B counts 3 points, a C counts 2, a D counts 1, and an F counts 0. So our grades were A, B, C, F. Credit. There's a 3-credit, a 4-credit, a 3-credit, a 3-credit, a 1-credit. Because this is what you usually see on your transcript. You'll see the grade, and you see a number next to it that tells you how many credit hours that class was. And your grades are the X, the credits are the weight. An A counts 4 points. A B counts 3 points. A C counts 2, and an F counts 0. So the next thing you do is multiply your grade, the number for your grade and the credit hours. So 4 times 3 is 12. 4 times 4 is 16. 3 times 3 is 9. 2 times 3 is 6. 0 times 1 is 0. Remember, your grade is the average of the grades times credits. So you have to add up all those first. 12 plus 16 is 28. Plus 9 is 37. Plus 6 is 43. Divide it by the number of credits you took, the W's. 3, 6, 9, 10, so it's 14. So it's 3.07. That's the grade point average. So does a student have an A, B, C, D, or F average? A B. Because an A goes from anything bigger, it's 4.0. A B is anywhere from 3.0 to 3.9. C is 2.0 to 2.9. D is 1.0 to 1.9. And F is anything below 1.0 to 0. So it's 0.9 to 0. That's an F. And what we usually did was, if you make a C in one course, how many A's do you need to bring that up to a passing grade? So that's what we used to do to keep us honest and in class. Any questions? So that's the first section of chapter 3. So that deals with mean, median, mode. The averages, the frequently occurring.